Thank you, and thank you for the invitation. Maybe I could add to the intro that Granlund is a consultancy that works both with technical building systems design as well as consulting for environmental impact. So that's part of why we were very interested in looking into this combination of how to make the HVAC industry more sustainable so that we could also meet our own goals when we design projects. So Atte was giving us a really good background of why this is important. I would like to add some figures to why the linear practices are so problematic and why EU is setting all of these targets. So the built environment still relies really heavily on linear practices. In Finland, about 1/3 of all climate emissions come from the built environment. It's about the same on the EU level. When we make, use, and waste, we're also producing 1/3 of all the waste in our country and in our region. Construction uses about 50% of all virgin resources and causes about 1/3 of the global biodiversity loss. So these are big figures, and if we are going to tackle these environmental challenges, then construction can't stay out of it. But so why then HVAC? Atte was touching on that already. I have some similar figures from the Finnish side. So we have an energy industry that is quite decarbonized already, which is why the operational energy use, the dark gray section over here in the example diagram, is quite small. The diagram shows the climate impact of an example school building, so a new build. And as you can see, the manufacturing of materials makes up more than half of the climate impact of this building over a 50-year evaluation period. But if we break down that orange segment, you can see it on the right, then we find that actually technical building systems are the biggest single contributor to these emissions. So that means, of course, also the building owners, the ones commissioning these construction projects, they've seen these figures too, right? And they need to lower their climate impact because starting from the beginning of next year in Finland, we will have whole life carbon limit values on construction. On an EU level, that will be the reality starting 2030, so it's not that far away. So I'm bringing you sort of insights from the future because we're already working with that on our building projects. And it means that when we have a limit under which we need to stay with the whole life carbon, and we look at where the contribution comes from, and we see these diagrams, then it becomes kind of a no-brainer to start optimizing the HVAC systems. And technical building systems in general. Lighting is a big contributor as well. And when we start doing that, of course, choosing products with a lower environmental impact is one key solution. The environmental product declarations become really important so we can compare different products. When making purchases, the companies will be comparing. There might be a limit set for example, ventilation system. The project might have a cap for how much the overall climate impact of the ventilation system can be. And then we start optimizing products within that system. But reuse is also a really central strategy. And part of why reuse is also interesting is when we look at where the impact over the 50-year lifespan comes from. So the gray here is the impact that comes up front when we build the building. And the orange bars indicate the impact during the lifespan, so when we're replacing parts during the lifespan. And if we look at non-residential building types, then the replacement of parts is actually a huge chunk. Partly it's because those parts wear out, but partly it's also because there might be tenants moving in, tenants moving out it's not necessarily that the part itself isn't servicing anymore. It might just be that the use is changing. And the traditional way has been to gut everything and put everything new in, but that's not going to fly anymore. Of course, decarbonization isn't the only incentive for reuse. Atse was in on that as well. I'm not going to go too deeply into it because we don't really have time, but of course corporate strategies play in. We have property owners who have really ambitious climate targets. They can't keep doing things the way they've been doing it. So in Finland, what we did was we had a joint project where we tried to explore the refurbishment and reuse possibilities and identify what the bottlenecks are. Because if there's something we know about circularity, it is that nobody can do it alone. The product manufacturer can't do it alone, the property owner can't do it alone, the contractor can't do it alone, the designers certainly can't do it on their own. So we needed to get everybody together so that we could look at what the problems are, where we actually are at the moment. We realized, surprisingly, that there were a lot of circular initiatives going around, but maybe the people doing it didn't even know to call it circular. It was just, it makes sense, it's cost efficient, it's smart. And then we wanted to test the project, the process in some real life pilots, and then produce guidelines for all the stakeholders. So we also wanted to document what went wrong, what could have been done better, how it should be done, so that people could learn from our mistakes. So this is a picture from one of our pilots. This is the state of circularity at the moment in office refurbishments a lot of the time. The contractor comes in and sort of smashes everything up, throws it away, and puts in some new stuff. But this obviously is not how it should be if we're going to be circular. So the challenges, on the one hand, as we have been touching on before, product development is quite rapid. So we also, while we want to lower embodied carbon, we also want to have energy efficiency. How do we marry those two? Contractors' revenue models are often based on getting a commission of the new products that they bring in. That is a challenge. Inadequate data flow is a huge problem. So if we don't know what products we have in the building, we don't know their properties, how are we going to know whether they're fit for reuse? And also a low awareness of possibilities. We might have a product manufacturer that's very interested, and a client that's very interested, and a designer that's very interested, but they're not talking to each other. Nobody's saying, we want to develop this further, will you come and do it with us? But everybody needs each other. There isn't a good marketplace where these products could be exchanged the way that new products are. Although we're finding that in Finland, for example, some of the wholesalers are very interested in having like a second-hand line of offerings. So that's also something that might be in the works in the coming years. And then, of course, there's legislation, for example, on refrigerants and liability and warranty issues, which are no small questions. But so what we did is we assessed the refurbishment and reuse potential of different parts. So the criteria here for us were if it has high embodied emissions or a high cost, then it might be worth putting some effort into getting it reused. That doesn't mean that the ones marked in red shouldn't be reused if that works for the individual project. That's up to them. But especially if your product as a manufacturer is marked in dark green, then it probably means that there's some potential there for you. So what we did in our pilots was both dismantling and reinstallation. But I'm going to especially take a look at the dismantling here because that is quite interesting, and I think in the dismantling is perhaps where the product manufacturer can play a significant role. Because if the product is dismantled intact, delivered, for example, back to the manufacturer. You can refurbish it, you can sell it. After that, actually the assembly process for using it again doesn't really differ much from using a new product. So of course, at first we had to evaluate the reuse potential. This is where the data flow problem comes up. We had to assess what was already in the building. Ideally, we would have this information already in digital form, maybe in digital twin, but at least for these buildings, we did not. So the designers had to dig through previous documentation, PDFs, paper documents, and try to find what models did we have from what year, how had they been maintained, and that took a lot of time. Once the reuse potential had been evaluated, we went back to the client and we said, look, we think these and these parts could be reused. What do you think? This is approximately the amount of effort it would take for each individual part. And the clients then went over the list and we made a plan. Then we made a dismantling plan. This is part of a normal process if we're going to renovate something, so there is always a dismantling plan, but this time it had to be really detailed. So we had to know, where we can take the sledgehammer and smash things up the way we used to, and where we really need to be very careful, and how do we determine, which all parts do we need to incorporate, what do we need to protect from dust, what can definitely not get scratched. Maybe there's something that needs to be delivered to storage because it's too big to keep on the construction site. So all of this planning was quite different from the regular process. Then the contractor came in, they started to do the dismantling. We learned the documentation that they should have had, but didn't because we hadn't yet realized that they should have documented some of those things. So it's also very important that during the dismantling process, the contractor then documents their own work so that we know, for example, which part came from which room. Maybe, something was dented on the way. How do we know where, along which part of the process did it happen, so that we can discuss then the liabilities and those other issues. And then transportation, storage, possible refurbishment is the last step. And this is where the product manufacturer also comes in, because of course right now, it might be like a guy with a workshop somewhere who says, yeah, I can probably fix it, but that doesn't really instill confidence in the other parties involved in this process. But if the product manufacturer can come in and say, we have a take-back system, if you dismantled it according to our instructions, we'll take it back, we'll check that it works, we'll give it a new warranty, and we'll ship it back to you. That's a no-brainer, right? Everybody would be very happy to have that kind of product manufacturer on board. So lots of questions still to be ironed out, but we published the guidelines now. There's a process description for each step of the way, and it's broken down by actor so that every party involved knows what am I supposed to do to make this work, and who with and at what point. As our findings, we found that reuse or refurbishment is most attractive, obviously, when the product is easy to dismantle intact. This is also a pro tip to you manufacturers. Are you considering this in your product design? Also, as I mentioned before, if there's a high carbon footprint or a high cost, it's worth considering reuse refurbishment models. When refurbishment is simple, so either the manufacturer is involved or it's just technically very simple, so anybody can do it. If your product is hidden, so there's no aesthetic requirements, it doesn't matter if it's a little bit old looking, then that really helps. Or if the product can be updated or reused on site. So maybe you can just change a fan, change a filter, change something small, and it works without having to ship it anywhere. Just briefly before I finish, the overall climate impact of our office renovation pilot was actually reduced by over 50%. So that was a massive reduction. This was a very small renovation. It was only about 400 square meters that was renovated. But this reduction was really huge. And so the property owner that was involved was very much motivated to keep pursuing this in the future. And yeah, circular business models doesn't need to be just selling old equipment back. There's lots of models, and many manufacturers are doing them already to some extent. So you just need to find what works for you. Thank you.